So today we'll talk about patterns and sequences. Specifically, we'll be talking about patterns by inspection, patterns in art, patterns in nature. We will also determine the next term in a given pattern, and we'll also talk about the Fibonacci sequence. I have a separate video for solving on sequences and series, arithmetic and geometric. So let us proceed. So what is a pattern? A pattern is an arrangement of numbers, objects, shapes, colors, or events that follows a predictable rule. So an example to this one is if we take a look at these numbers, 2, 4, 6, 8, and 10, what can you say? So it is readily observable that the pattern is plus 2 every time. Okay, so the pattern is very clear. Let's try to have another example. How about this one? What can you say about this pattern? Okay. So the pattern in this one is, okay, there is an alternating sequence of triangle and circle. So the next term for this one is expected to be a circle. Okay. And then, okay, we have a third example. How about this one? Okay. So what would be the pattern? Okay. So the pattern to this one is, okay, there is an alternating colors of orange and green. So I think now pattern is already familiar to you. Okay. So in nature, we also have patterns, okay? Because God's creation is very nice, very beautiful. So there are patterns also in nature. Nature follows mathematical rules surprisingly often. Now, there are many things that we commonly see, and then we did not know that it follows a mathematical rules. So an example is, okay, if you try to look at this one, this is a sunflower, okay? So seeds form spirals. So if you look at the seeds, it's not really circular, no? It is spiraling, okay? And the numbers of spirals often belong to the Fibonacci sequence. So in the later part, we'll be talking about what is this Fibonacci sequence. Let's try to have another example. Example in nature, patterns in nature is this one is a pine cone, okay, or pine cones. So you can also see a pattern. So the scales form spiral patterns. Fibonacci numbers commonly appear. Okay. So another example, patterns in nature is this one. This is a really amazing thing in nature. So this is a honeycomb. So if you observe exactly, so bees build perfect hexagons. So perfect hexagons. Because hexagons store the most honey while using the least wax. So that is the beauty of nature. Example number 4. So we have snowflakes. So although these are really small, but if we try to look at it closely, okay, this is what they look like. So they have six-fold symmetry, and every snowflake is unique but follows geometric rules. So that is mathematics is amazing because mathematics is relating to nature. Example number 5. You know what is this? Okay, these are zebra stripes. Now, patterns differ for every zebra, much like fingerprints. So, contrary to what we expect, zebras have similar patterns. No, they really do not have. So, they have unique patterns. It's like fingerprints, just like us. Example number 6 is this one. So, we have shells. Some shells resemble logarithmic spirals. So, if you can see the spirals, okay, so this one is really amazing. So those are some examples of patterns that we can see in nature. We also have patterns in art. So what are the examples of this? So by the way, patterns in art, these are artists use mathematics to create beauty. So mathematics is really amazing. Okay, and example number 1 is this one. Maybe this is a tile. So what is being highlighted in this one is the symmetry. If you try to look at the picture, okay, at the center part, there is a line of symmetry. It's like you are looking in your image at the mirror. Okay, another example is this one. What is this one? This is a repetition. So these are commonly seen on floor tiles, something like that. Okay, we also have this one. This is called tessellation. So when we say tessellation, the shapes cover a surface without gaps. So in tiles, as an example, so we can see that every piece is really fitted to each other. So the surface will have no gaps. Okay, in example number 4, this is, what are these? These are called fractals. Okay, and example number 5, okay, you can see here an image. And the thing that is being highlighted here is the golden ratio, which is 1.618. When I say golden ratio, it is used by artists to arrange objects. So for an object to look really nice, arrangement matters really greatly. So one thing to consider, if you'd like to study about arrangements, then you could have your study on the golden ratio. Now let's talk about describing patterns by inspection. When we say inspection, if we try to have a first glance at something, so you have looking carefully without performing advanced calculations. So we use our eyes simply by this one. So an example is you take a look at this sequence of numbers, 5, 10, 15, 20, and 25. What can you say about this sequence? Okay, so each number is increased by 5, increasing by 5. So the pattern is very much readily observable. Okay, so another example is this one. Okay, 3, 6, 12, 24, and 48. So what is the pattern here? Yes, the pattern is each number is doubling. So 3 times 2 becomes 6, 6 times 2 becomes 12, and so on. Another example is this one. Anybody can guess the pattern here? Okay, so the pattern here is perfect squares. So you have 1 squared is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. So those are perfect squares. Now, how would we determine the next term? Okay, so this is the part wherein our minds will be challenged. Okay, in example number 1, 8, 11, 14, 17, 20. So what is probably the next term? Now, if we try to observe the numbers, you can see that the difference is 3 because for 8 to become 11, you have to add 3. And for 11 to become 14, we add 3 and so on. So the difference is 13. Now, what is the expected number here? Yeah, very simple. The answer is 23. It's pretty much elementary. Okay, example number 2. How about this one? What is the pattern? Okay, the pattern here is it's doubling or it is multiplied by 2. So based on the sequence, the next number would be 160. So those are just pretty easy examples. Example number 3, 2, 5, 10, 17, 26. Okay, there is a little bit challenge here. So what happens now is 2 to become 5 is added by 3. 5 to become 10 is added by 5. 10 to become 17 is added by 7. So you see the pattern? Okay, so the difference are 3, 5, 7, 9. So for short, uh, odd numbers are being added to each term. Okay, so what will be the next? So since 17, the thing that is being added to 17 to become 26 is 9, and since these are odd numbers, the next odd number is 11. Okay, so the next difference would be, yes, 11. Since we have 7, 9, the next difference is 11. And you know what? What would be the next number? Okay, the next number would be 37. Yeah. Okay, so moving on. So what we'll try to do now is we will try to identify the rule. So what is the rule that's being used? So suppose we have the numbers 4, 8, 12, 16, and 20. So what is the rule that's being used here? Okay, so we can see that 4 becomes 8, 8 becomes 12, 12 becomes 16, and 16 becomes 20. So observing, okay, we can see that there is a common difference of 4. So if the rule here is we are going to add 4. So simple as that. Okay, another one. 7, 14, 28, 56. Okay, what is the rule here? Okay, So as you can see, the rule here is we are multiplying by 2 because 7 times 2 is 14, 14 times 2 is 28, and so on. Another one, 1, 8, 27, 64, 125. What's the rule? Okay, so the rule here is this cubing. Okay, we cube numbers. So 1 to the power of 3 is 1, 2 to the power of 3 is 8, 3 to the power of 3 is 27, and so on. Okay, so you're already guided. Okay, so the next one is a very nice one that we call the Fibonacci sequence. So it's probably the most famous sequence. When we say Fibonacci sequence, it starts with 0 and 1. And next thing that happens is we add the previous two numbers. So from here, 0 plus 1 is 1, okay? And the next number would be the sum of the previous two numbers. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 equals 5, and so on. So that's the Fibonacci sequence. So here is the illustration. That is the clear illustration. So next to 8 is 13 because 5 plus 8 is 13. Okay. So what comes after 13, 21, 34, and 55? So guess what? Okay. Since what you're going to do is we will try to add the last two digits or the last two numbers. Then 34 plus 55 is just simply 89. So the next number is 89. Okay. So where is it found? There are many things wherein we can observe the Fibonacci sequence. So we have flowers, like the sunflowers, pine cones, as mentioned a while ago, hurricanes. If we try to look at the hurricanes, so it follows the Fibonacci sequence also. Shells, and many more. Okay, so our next video will be about sequences and series of arithmetic and geometry. So I am separating it in other videos so that uh, the video will not be too lengthy. So please watch it also. Thank you.